In this video, we're going to do example 3.3.4, where we are asked first to calculate all four second-order partials, as well as one third-order partial for f of xy is equal to the sine of x squared y. So let's start by calculating the first partial with respect to x, so del f del x, which means that I'm taking the derivative here with respect to x, so I need a chain rule. The derivative of the outside is derivative of sine is cos. Keep the same inside function, so cos of x squared y times the derivative of the inside function with respect to x, and so that derivative is 2xy. I can also go and take the first partial with respect to y, so let's do that. You'll wonder why my spacing is so wide here. I'll show you in just a second. So we're going to take the derivative of the same expression now, but with respect to y. So I need a chain rule again. Derivative of sine is still cos of x squared y, but times the derivative now of the inside function with respect to y, which is going to be x squared. Now from each of these, I can calculate a second partial. This is why I left a lot of space. So if I go from the first partial with respect to x, I can calculate two more partials, again with respect to x and with respect to y. So let's calculate with respect to x again, so del squared f del x squared, which means I'm going to take the derivative here with respect to x. So this is the same thing as take the derivative with respect to x of the partial with respect to x. So take the derivative with respect to x of here. We have two terms that are being multiplied together, so we need a product rule. So derivative of the first, derivative of cos, is minus sine. So minus sine of x squared y times the derivative of the inside. The derivative of the inside is, with respect to x, 2xy, which is already sitting outside. So we've got to multiply that by 2xy and then by 2xy again, so 2xy squared. Now that was the beginning of a product rule, so we have to add. That was the derivative of the first times the second, so now it's the times the, or plus the first, so cos of x squared y times the derivative of the second with respect to x. So the derivative of 2xy is just 2y. This partial now, we just took the derivative with respect to x, we can take the derivative with respect to y. So we will get del squared f del y del x, which means take the derivative with respect to y of that first partial with respect to x. So that means I'm taking the derivative of this expression now with respect to y. It's still a product rule. So I'm going to get derivative of cos, which is minus sine of x squared y, times the derivative of the inside, but now with respect to y, which gives me x squared. X squared times 2xy will give me 2x cubed y, so 2x cubed y, plus product rule, the first, cos of x squared y, times the derivative of the second with respect to y now, so times 2x. We're going to do the same thing with the partial with respect to y. We can calculate two more partials, each with respect to x, or one with respect to x, one with respect to y. So del squared f del x del y, which is take the derivative with respect to x of what we just did, del f, or not what we just did, but what's written down here, del f del y. The next thing, I'm going to need a little bit more room. I'll give myself just a little bit more space. Here we're going to take the derivative, so del squared f del y squared, which is take the derivative with respect to y of the first partial with respect to y. So let's calculate these in turn. So here, now I'm working on this expression. I'm taking the derivative with respect to x of this expression. Product rule, so I need minus sine of x squared y times the derivative of the inside with respect to x, which is going to be 2xy. 2xy times x squared is going to be times 2 x cubed y plus cos of x squared y, the first, times the derivative of the second. Derivative of x squared is 2x. And you might notice something there, but we'll hold that thought until part B. If you haven't noticed anything, well, don't worry. We'll point it out in part B. Last of the second order partials, we're asked to take the derivative with respect to y of the first partial with respect to y. So we're taking the derivative here with respect to y. X is a constant, so this is going to be our shortest. We have the derivative of cos, which is again minus sine of x squared y times the derivative of x squared y, which is x squared times x squared, the constant outside, so times x to the fourth. We're also asked to calculate f sub xxy. Let's do that in just a second. Let's point out b. What do we notice about f sub xy and f sub yx? Well, let's first remember our notation. F sub xy is del squared f del y del x, and f sub yx is del squared f del x del y. And what do we notice about them? Here and here, they are equal. And are they always equal? Well, hold on for just a moment. Our takeaway 10, which is theorem 3.3.1, will give us the answer to that. But we have one part left to do for part A, which is f sub x, x, y, which, using our notation with the dels, is del cubed f del y del x squared, which is saying take the derivative with respect to y of the second partial with respect to x, del squared f del x squared. What I said, the second partial with respect to x, that doesn't make sense. Del squared f del x squared. So that means our del squared f del x squared, that's sitting up here. This is the expression that we want to take the derivative of with respect to y. So this expression is going to involve a product rule in the first term and a product rule in the second term. So hold on to your seats. So the first, we need a product rule here. Derivative of the first, derivative of minus sine is minus cos. Keep the same inside function, x squared y, times the derivative of the inside function, which is x squared. I'm taking the derivative with respect to y. So that's x squared, so I'm going to get times x squared times the 2x y squared, which is already there. Now we have the first here. So minus sine of x squared y times the derivative of the second. The derivative of the second, the way it's written, it's going to be a chain rule. So we're going to get 2 times 2xy to the first power times the derivative inside with respect to y, which is going to give me 2x. That is just the first term. Now we've got to do a product rule for the second. So plus, and if I do this, I'm taking the derivative of the first, which is actually going to give me a minus sign again. So I'll erase my plus. And let me carve out a little bit of space here. So minus sine of x squared y times the derivative of the inside with respect to y. So times x squared times the other term, times 2y, plus, and we're almost done, cos of x squared y times the derivative with respect to y, which is just 2. So takeaway 10, the equality of mixed partials. This is theorem 3.3.1, otherwise known as Claire-Roe's theorem. if f of xy is defined on an open disk containing the point AB, and if f sub xy and f sub yx are continuous. So these functions, their continuity plays an important role. If that condition is met, then the mixed partial xy at AB is equal to the mixed partial yx at AB. So what we observed here in part A, the equality of those mixed partials, happens very often because very often we deal with continuous functions, but if those second mixed partials are continuous on a disk around AB, they will be equal.